Hello students, all students are welcome to my chemistry class. Today I will discuss about oxidation number. An element in a compound remains either in oxidized condition or reduced condition, or it may be neutral. The number by which we can know the oxidized condition or reduced condition of an element in a compound, that is called oxidation number. The oxidation number of an element in a compound or in an ion. The oxidation number of free element is considered to be 0. O2, N2, iron, copper, sodium, etc. Number 2 is in ionic compound. If the ion is formed from single element, in those cases, the charge of the ion is the oxidation number of that element. That means Cl minus, the oxidation state of chlorine is -1. N3 minus, nitride ion, the nitrogen is -3. Similarly, Na plus, the sodium in +1 state, calcium 2 plus, in +2 state, etc. For multi-atom ions, the summation of total oxidation numbers will be equal to the charge of the ion. Suppose PO4 3 minus, phosphorus is here +5 plus oxygen is -2, so it becomes ultimately -3. Normally, the hydrogen containing compounds, the normal oxidation number of hydrogen is considered to be +1. Suppose H2O, NH3, etc. hydrogen is +1. But in hydride compounds, suppose sodium hydride, lithium hydride, calcium hydride, these compounds hydrogen is in -1 oxidation state. In sodium hydride, lithium hydride, in calcium hydride, in metal hydrides, the oxidation number of hydrogen is -1, because in those cases sodium, lithium, calcium metals are more electropositive than hydrogen. So metals are in positive oxidation state and hydrogen in this case negative oxidation state. Normally, in the oxygen compounds, the oxidation number of oxygen is -2. Suppose H2O, CO2, etc. In those cases, oxygen is -2. While peroxide compounds, oxygen is in -1 oxidation state. Some of total oxidation numbers in a compound is 0 as the compound is as a whole neutral, chargeless. Suppose KMnO, potassium is +1, manganese is +7, plus oxygen is -2, this is equals to 0. So if you try to determine the oxidation number of manganese, suppose the oxidation number of manganese X, in this case +1 plus X plus 4 into -2 equals to 0, then X equals to +7. In this process, we can determine the oxidation number of the element which is not known to us. I am citing here some typical examples. With this formula, we can now determine the oxidation number of the element in that compound. Suppose CrO. There is a peculiar structure. This is called butterfly structure. This is this type of structure. In this case, it concerns all the bonds. This bond contribute -1 to oxygen and +1 to chromium. And similarly, this bond -1 to oxygen and +1 to chromium. So as I said, the oxidation number of chromium is +6 here, not +10. I am citing another example, H2SO5. In this case also, we have to draw the structure. H2SO5. You see, from this, if we apply the formula, we get the oxidation number of sulfur as +8. But considering the structure, each one contributes +1 to sulfur, -1 to oxygen. So calculating in this way, we will get +6 for the sulfur. You have to consider here the peroxide linkage, so the confusion becomes. So in H2SO5, the oxidation number of sulfur is +5. In Na2H2O3, this is a peculiar structure. Na2H2O3. This bond contributes -2 to sulfur and +2 to sulfur, this sulfur. And from this bond, -1 to oxygen, +1 to sulfur, -1 to oxygen, +1 to sulfur, -2 to oxygen, +2 to sulfur. So -2, -2, -2, -2, +4, -1, +1. The oxidation number of this sulfur is +6. In this case, this bond contributes none to both sulfur because this is sulfur-sulfur linkage. Okay. So in these cases, the oxidation number of sulfur is +5 and that of sulfur is +5, and these sulfur atoms are in 0 oxidation state. In organic compounds, you have to draw the structure. Suppose acetone, The oxidation number of this carbon is hydrogen plus 1 minus 3. This also minus 3. And this carbon, this won't contribute none to each other. So this carbon is in plus 2 because oxygen is minus 2. In some cases, the oxidation number may be 0. Suppose the glucose C6 H12O6. Hydrogen is plus 1, so plus 12, minus 12. Carbon is in 0 oxidation state. So this is all about oxidation numbers. Thank you all for viewing my channel and attending my chemistry class. Thanks.